Thank you so much, Boris. And what a privilege and an honor to be speaking in Australia. We've been, I think we've been trying to arrange a trip to Australia for some time, and COVID has not been our friend. So this seems to be the way to do business nowadays. And anyways, thank you so much for the opportunity to talk about our experiences in British Columbia and in Canada. So I'm just advancing the screen here. So what this talk is going to be about is retrospective impact of this systems used for life safety and fire spread. Fire safety risks posed by large wood frame residential buildings. We're going to touch a little bit on CLT. And this talk is about the concerns that were raised through a number of periods of development in the building codes in British Columbia and in Canada, and how these systems were looked at in order to create a comfort for our industries, fire services, and building officials on how these concerns would have been mitigated with the new changes to the building code. So as Boris had pointed out to you, I've got a background, an academic background in criminal justice and social research. John Jay College, shortly after the connection to John Jay, as they stood up the Christian Reagan Center after the World Trade Centers collapsed, and they focused on building vulnerabilities in high rises around the world, and have been studying that, and it's been a privilege to be part of that. And currently I did retire in June of 2019, but I do serve as a senior advisor for the Centre for Social Data Insights and Innovation for Statistics Canada. And my colleague, Dr. Joe Clare, who's the Director of Criminology at the University of Western Australia, he's an interdisciplinary social scientist, and his history of applied research in university and governments in Australia and Canada, and a commitment to the nexus between theory and applied research and practice. And he's an international member of the Institute of Canadian Urban Research Studies at Simon Fraser University. And most importantly is when I met Joe was in 2010. We hired him for the Surrey Fire Service as a strategic analyst, and that the timing was perfect because we were raising issues at that point in time about mid-rise construction in British Columbia and all. That's kind of where this talk is going to start. So I was fortunate in my career to be asked by the Canadian Association of Fire Chiefs to put together an aggregation of national fire data across Canada. It was a demonstration project that the federal government granted us. It was nearly $1 million to aggregate and conduct research based on our aggregation of data. We weren't able to fully aggregate all of Canada's fire data, about 72% of the population. And a lot of this work focused on questions that were asked of that database. So essentially, what this talk is about is examining the relationship between method of fire control, fire safety systems, fire outcome, fire spread, and casualties, with a focus on analysis on the areas within residential properties that experience a disproportionate number of fires and fatalities, and to consider the potential for enhancing fire safety in residential buildings in a targeted manner. So what the data set held was 439,256 fire incidents between 2005 and 2015, 6 Canadian provinces and the DND, which is a Defense National Department of Canada. There was 129,900 residential fires that we retained and analyzed in this data set. This included 1,418 fire-related deaths and 8,900 injuries. And as a point, 97% of the fires that occurred in residential buildings without sprinklers resulted in 97% of the injuries and 99.2% of the deaths. And 78% of the deaths had no functioning safety system, smoke alarm, or sprinkler at the time of the fire, which is a major concern. What we discovered in that database was woefully lacking just in the basic fundamental aspect of a working smoke alarm, only 30% of the fires that occurred in this entire data set overall had a working smoke alarm. So there's a lot of work that needs to be done in Canada in order to change citizen behaviors. So the National Fire Database, for the most part, the data dictionary and a high-level report and a sustainability for the next steps for the project is on the Canadian website for Statistics Canada and can be downloaded. And if there's an interest for access to that later on, I can share that with Boris based on the questions. So just as an example of what you might find is basically the number of records within the National Fire Incident Database. It included, as I said, 6 provinces, armed forces, New Brunswick, Ontario, Manitoba, Saskatchewan, Alberta, and British Columbia. As I said, 2005 to 2015. The number of incident records per year per each province. Fire incidents at a glance, 7 jurisdictions in terms of the number of actual total fire incidents in structures, and below the 6 provinces as a percentage of the Canadian population, and the number of victim records that were in the database. And just a bit of a geographical look at the provinces and the makeup of Canada and the provinces that participated in the initiative. And it's pitched against, at that time, a population of 35.5 million people in Canada. And so what we're talking about here is large wood frame residential buildings. And as I alluded to, in 2009, the province of British Columbia adopted and advanced the building code amendment to allow from 4 to 6-story wood frame construction. And in 2005, the National Codes Canada adopted a similar building code to allow for up to 6 stories in wood frame construction. And it was important to note in 2009, at that time in British Columbia, there was a lot of concern, primarily because there wasn't a lot of historical experience with combustible buildings as these were defined, or experience in these types of buildings. And obviously there was some concerns from fire services, building officials, etc. So this talk generated in about 2010, along with the time that I was elected as the president of the BC Fire Chiefs Association. And what was very important at the time is Joe Clare had started work with us in the city of Surrey, and we set out to try and answer those concerns and issues associated with this type of construction so that we could quell or comfort the concerns, or we could identify what those vulnerabilities were in these types of buildings and actually see how they may perform in this particular situation. So challenging the implicit assumption was the instinct from fire services was, in respect to wood buildings, they're taller, therefore they're going to be more risky in terms of fire and safety. So we brought out 3 perspectives: what the developer sees, what the community sees, and what the fire service concerns were when these issues were adopted. So of course, what the developer sees is these massive, big footprints of construction. And I might add, you know, some of the benefits and why the province of British Columbia advanced this type of construction was to try and bolster its wood industry in terms of a greater use of wood. It's one of our natural resources, and it represents a large share of employment and revenue for export plus construction in the province of British Columbia. And they wanted to advance that, stabilize and advance that. So the natural move was in order to see these additional 2 stories being added to these buildings. And it wasn't actually really quite that new, because when we did our research, we found that in the western portion of North America, for example, Washington, Oregon, and California, mid-rise buildings up to 6 stories were being built for the last 20 years. And there was a lot of experience with those issues. We interviewed fire chiefs and fire officials on the Western continent, and for the most part found that these buildings were not performing badly against fire as what may have been concerned by our colleagues. Of course, what the public sees is these beautiful buildings that are icons in our neighborhoods. Compact living is something that is becoming very predominant, especially in the lower mainland regions and the city cores, and higher density, greater taxation, and this type of living is going to be the future. Our children need a place to live, and construction is getting very expensive, and this type of approach is more and more commonplace. And as obviously since 2015, all of Canada has been accommodating this type of construction. And of course, what the fire service was concerned about was these massive wood buildings and what happens when they catch fire. The characterization that you're seeing here are all of these buildings were under construction, and I'll talk a little bit about some of those vulnerabilities. The one on the left-hand side occurred under my jurisdiction at the time in the city of Surrey, and that long column of smoke in the center was the view of my as I was driving into work that morning where this fire occurred. And it was very challenging, and we have some advice on those types of things as well. So specifically, what the fire service had raised in terms of concerns were the expressed lack of research or evidence to support this going forward. Harmonization, it wasn't consistent with other building codes, and consultation. They were wondering about the fire safety systems performance, response times, resourcing, and construction fire safety. And the changes, the major changes that took place, there were many of them, but this is basically highlighted in 2009 and in the National Building Code of Canada 2015 was compartmentalization, fire-resistant assemblies, and one of the major issues was more stringent sprinkler protection. Now, in Canada and in British Columbia specifically, I'll talk about British Columbia specifically about sprinkler protection. There are probably in the neighborhood of about 40 large municipalities, including the city of Vancouver, that nearly 10, 15 years ago, some of them adopted mandatory sprinklers for all construction, including single-family dwellings. And as I said, there's nearly 40 municipalities over the last quite a number of years that have adopted sprinkler protection. And of course, the industry, fire service industry, has been lobbying the national building code process for mandatory sprinklers across the board, and they have not been able to achieve that. All of the mid-rise construction, anything over 2 stories that is not a single-family dwelling, if it's an apartment building in British Columbia and Canada, would be sprinklered. And the mid-rise construction, and it's sprinklered to 13R, which is residential. A dwelling is 13D, NFPA. And in this particular case, for mid-rise construction, they adopted 13, which meant that every cavity and area that is of a certain size would be sprinklered. So the attics, the balconies, confined spaces, everything is sprinklered. And this has actually been a benefit, and we've seen the difference in terms of some of the catastrophic fires that have occurred. And in British Columbia and across Canada, we can tell you that one of the vulnerabilities, or one of the worst vulnerabilities, were fires that occurred on balconies, and it represents about 18% of all multifamily dwelling fires occur on the balconies. And when that occurs, it's phenomenally worse. And I'll give you an example. In British Columbia, over the last 10 years, we looked at 6 fires that occurred on balconies at $1 million a loss. And since the mid-rise building code has been adopted, where fires have occurred, where there have been sprinklers on balconies, the loss was around $5,000 per fire. And we're doing some research and a study and a report on that as we speak. Of course, the other concern was moisture content. These are great big buildings and they shrink a lot. So there's a lot of thought that needs to go into it, and the moisture content has to be monitored carefully. And construction risk mitigation is another big issue. So one of the big questions that came up in the beginning was, does construction type make a difference, i.e. combustible versus non-combustible? All of these research reports are available on the University of the Fraser Valley's website, and you'll see a link to that at the end of the presentation. So in the first part, we reviewed fires that occurred in British Columbia between 2008 and 2013. There was nearly 12,000 fires that were incidents that were retained for this analysis, 107 deaths and 772 injuries. We looked at fires that occurred in the following 5 construction types, which we identified at the time of the fire in the reports. And it's combustible construction with open wood joist, protected combustible construction, wood protected by plaster or gyprock, heavy timber construction, non-combustible construction or exposed steel, and protected combustible construction, protected steel or concrete. Looking at the nearly 12,000 incidents, we looked at the frequency of fires, deaths, and injuries by general construction type, extent of fire by general construction type, the frequency of fires, sprinkler protected, smoke alarm activation, injury rate by general construction type, extent of fire by general construction type and protection type, the method of fire control by general construction type, fire-related casualties by injury by general construction type, and fire-related casualties by construction type in the presence of a working smoke alarm and sprinkler protected, which was the key. So when we put all these together and we run it in parallel, as you'll notice with all of the 5 construction types, in terms of the numbers of fires that were contained to the object of origin, part of the room, confined to the room, confined to the floor of origin, confined to the building of origin, or extended beyond, or confined to the roof attic, you'll see that by those trajectories that every one of those types seem to perform almost identically, with the exception of fires in heavy timber, which were basically exposed, which meant that there was probably a little bit less resistance to the fire at the time. So when we line this up, when we just start focusing on the smoke alarm activated and the sprinkler protected fires, there were 865 of those, and then the first highlighted area was protected combustible construction wood protected by plaster and gyprock, which was 413 of those, 47.7% of the fires, 26 injuries, the injury rate was 63, and there was no deaths. When we look at protected non-combustible construction protected by steel or concrete, 308 of those, 16 injuries, and no deaths. So looking at it from a different perspective and comparing the 1 to 4 story fire outcomes as a function of fire protection systems and building protection systems and construction type, we lined up combustible and non-combustible on the left-hand side of the top. And we said, was there a sprinkler system? Yes, yes. Was there a smoke alarm that worked? Yes. The number of fires in the combustible environment, there's certainly more of them, or more combustible buildings, 1,558. Non-combustible was 593. The injuries with 99 versus 33, but the injury rate was 63 versus 55. 4 people died in the combustible environment. Death rate was 2.6. And the percentage of times that the fire department was called upon to fully extinguish the fire was almost identical, 22.8 versus 22.9, and spreading beyond the room of origin, where the fire occurred, 8.7% as opposed to 8.6. Now, looking at its cousin, which is the basically the 5 to 6 stories, and as I said, these have been around for about 10 years, and so we haven't had a lot of fires, but nonetheless, in a sprinklered environment for combustible versus non-combustible, and a smoke alarm, 146 fires versus 103. Number of injured was 6. The injury rate was 41.1 versus 58.3. No deaths, obviously no death rate. And the percentage of time that the fire department had to extinguish those fires was 13% versus 12.6. Spreading beyond the room of origin was 2.1% versus 4.9. So already we can see that the 5 and 6 story environment seems to be performing much better. The unfortunate thing is we need more fires to get some statistical comparisons. But based on what we have right now and the statistical tests that we found is that there was no a statistical difference on the percentage of fire systems performance between combustible and non-combustible. So the safety systems are really doing the job, and what the building was made of does not show up in the damage assessment of these buildings. So the conclusion, the short answer is, does construction type make a difference? And obviously the short answer is no. We found that casualties by construction type in the presence of a working smoke alarm and sprinkler protected, death and injury rates were similar. Fire spread was remarkably similar with no distinguishable differences between construction type. Most fires were confined to the room of origin. So once again, challenging the assumption, 2 comprehensive studies were done, which are available on the University of the Fraser Valley's website, cjr.ufe.ca, and you can download them for free, and they're good reference material. So now looking at the Canadian perspective and deaths per 1,000 in all residential fires and the fire rates. And once again, we were looking at the working smoke alarm and the sprinkler system, whether it was full or partial. And in the left-hand side, we're lining this up to say, well, if there was a smoke alarm and a sprinkler system, if there was no smoke alarm, yet there was a sprinkler system that worked, or whether there was just a smoke alarm and no sprinkler system, or there was nothing operating at the time. As I mentioned to you, we're woefully lacking in Canada in terms of maintaining smoke alarms. But we'll follow this through on the top line of basically a smoke alarm working and a sprinkler system working. There was 2,254 fires. Injuries were 169. The injury rate was 82.3. There was 6 deaths. Death rate was 2.9. 33.5% of the time the fire department needed to put out the fire, and it spread beyond the room 6.1% of the time. Now when we look at the next slide with no smoke alarm and a sprinkler system working, there's 1,526 of those, 92 injuries. Injury rate was 60.3, 6 deaths, and the death rate was 3.9, 33 or 34.9% of the time to put out the fire, and it spread beyond the room 14.4% of the time. And when there was just a working smoke alarm, the numbers get bigger, 38,750 of those fires. Injuries were 3,704, 95.6, 303 deaths, 7.8% of the death rate per 1,000 fires. 43% of the time the fire department needed to extinguish the fire. Spread beyond the room, 12.7%. So we're starting to see the trend here of how the safety systems affect the proxies in terms of the death rate, the percentage of the time the fire department needed to put out the fire, and how far the fire spread. So in the worst case scenario, where there was nothing involved, 87,580 of those fires, almost 5,000 injuries. Injury rate was 56.6, 1,100 deaths, 12.6%, or the rate of 12.6 per 1,000 fires. Fire department is extinguishing it 43.9% of the time. Spread beyond the room of origin, 21.9%. So it's a good proxy of how the systems are going to function, and we can predict the future on how that's going to work. So looking at this a little bit different way in terms of a bar graph and how it graduates itself, the death rate of a sprinkler system and a smoke alarm, 2.92, just a sprinkler system, 3.9, a smoke alarm only, 7.8, and when there's nothing involved or no systems functioning at the time, 12.6. Excuse me. The death rate risk reduction is 38% probability with a working smoke alarm, 69% with a working sprinkler system. Combine the two, 77%. And what we're looking at here now is maybe just focus a little bit on the civilian and firefighter injuries, because that was an issue that was raised by our industry in terms of fire rates around civilian and firefighters. So when we look at that best scenario on the top line again, you know, that the percentage of deaths, 6 versus 2.9% of fire or deaths per 1,000 fires. And on the firefighter side, we were able to identify that there was no firefighter deaths in that scenario. And then when we looked at just a sprinkler system, it was similar, but 3.9 as you've seen before. But focusing on the firefighter side of the equation in terms of their injuries or deaths, and certainly one death is too many for a firefighter industry. But when there was no systems in play, we had 2 firefighter deaths, and under that set of circumstances. So once again, looking at the Canadian perspective in terms of the percentage of fires that spread beyond the room of origin, in a smoke alarm sprinkler scenario, 6.1%. Just a sprinkler only was 14.4. Smoke alarm only is 12.6. And when there was nothing, it was 21.8. And you might be asking yourself, well, how is it that a smoke alarm outperformed the sprinkler system? And the best answer for that is what I can tell you is that the smoke alarm is probably going to activate and alert the person at home at the time a little bit quicker than what the sprinkler system would have gone off. And with a working smoke alarm, there's a chance that they're going to, the resident or the individual at home is going to intervene with that fire prior to it breaking out and causing damage or activating a sprinkler or sprinkler system. So we also know under this set of circumstances what the severity of those injuries were, and both civilian and firefighter. And under those set of circumstances, in terms of a working smoke alarm and a sprinkler system being present, and whether the injury was minor, 1 day off, light, 1 to 2 days in hospital or off work for 1 to 15 days, or serious 3 days in hospital or off work for 15 days. And so we recorded from that database, we knew what occurred. There was 6,927 civilian injuries that had that we could calculate with this cross-reference with this information, and there was 1,956 firefighter injuries. And you'll note that under the yes scenario, for civilians there was 80, for firefighters there was 10, and when we get to the no yes, there was 7 of those scenarios. In other words, in terms of no smoke alarm and a working sprinkler system. And under the circumstances of a smoke alarm working, yes, and a sprinkler system working, no, it was 597 injuries. And when we get to no, when there was no sprinkler system and no smoke alarm, 971 firefighters. And on the civilian side, in the no scenarios, once again, it displays it as being the worst case scenario for civilian and firefighter injuries in this set of circumstances. So what we're looking at now is kind of the graduated lineup of basically looking at all residential buildings that were protected by sprinklers, apartment buildings that were protected by sprinklers, and single detached buildings that had fires. There was 199 of those. And as you'll note, that you started from the left-hand side, which is the best case scenario when the fire is confined to the object of origin, confined to part of the room of origin, confined to the room of origin. And when we get to the area where it's confined to the building of origin, and we look at the concentration versus the right-hand side in the unsprinkled environment, we can see there's a much different picture in terms of the number of fires that are actually making it to being confined to the total building of origin, or even extending beyond the building of origin or into the roof areas. There's obviously a significant difference that's showing up in terms of what you can expect in terms of outcomes. So the other thing that we looked at is in the no sprinkler protection scenario, along with the sprinkler protected area, and we looked at what the action of the casualty was for injuries and deaths by sprinkler protection status. On the left-hand side, we can see there's no sprinkler protection, and the majority were injured while attempting to escape, but even a larger proportion entered or remained for firefighting extinguishment. And then on the sprinkler side, and then of course, the sprinkler side, we're looking at 1,440 versus 34, and entered or to fight the fire or extinguishment, 83 versus 3,491. So there's a huge difference in terms of how it's impacting life safety and injuries as a proxy of the sprinkler protected buildings. So kind of lining this thing up in terms of the cumulative percentage and the extent of fire spread by sprinkler protection status, 88.4% of fires controlled by sprinklers are contained to the room of origin, and that's the damage, of course. And then fires contained by sprinklers, 97.8% confined to the building of origin. 2.1% of the fires with sprinkler protection extended beyond the building of origin, compared to 8.3% of the fires without sprinkler protection. So your best odds, obviously, are for a sprinkler building. And so the next thing that I wanted to focus on is construction fire safety, and that is an incredibly big issue, and a lot of us have had experience with what's occurring in this the buildings that are under construction. They're very vulnerable, there's no doubt about it, and it's likely to say that the best prevention is for not to have a fire, because what we have experienced in almost all cases is once these fires get started in these buildings that are under construction, they're likely to burn to the ground. And both these documents are reports, one on best practices for construction fire safety, which is an accumulation of research that we found in North America and Europe and England. And on the right-hand side is construction fire response, which is basically a guide to fire services to help them make corporate decisions on how they're going to manage these fires if and when they do occur. And of course, these buildings under construction, they go fast. And I can tell you that there's probably no safe place for a piece of apparatus or a firefighter to approach these buildings when they do catch fire, because they are incredibly hot and they burn incredibly fast. We had construction fire safety plans in the city of Surrey at the time of the fire that I pointed out to you, which was in just past 2009. And it was a catastrophic event, and we learned a lot from that. And from that perspective, we bolstered our construction fire safety plans and our requirements under the fire code and instructions to the developers on how they were going to manage these buildings while they were under construction. Fire safety plan requirements, in essence, require training for all on-site staff, enforcement of best practices. So our prevention and operations staff will visit these sites on a periodic basis to make sure that they're being adhered to. Coordinating firewall construction as soon as possible, and making sure that where possible we can install fire doors as well that are either fused or whatever is appropriate to be closed. And site security, and we required an active watchman service. So somebody that is there all the time, 7/24, that's patrolling the area and ensuring that best practices are followed and that they understand and know who's coming and going and that the site is secured. And retrospectively, the leading causes for these fires that are under construction were incendiary or suspicious events. As I mentioned to you, the fire that we had in 2009 in North America, and I'm not sure about Australia, there was quite a severe dip in the economy. And the building that you see below was a building that was under construction. The fire occurred 10 o'clock in the morning, and it occurred in two places on each side of almost simultaneously on each side of a firewall. And so that was likely a suspicious event. And that project was extended by an additional 2 years. And so you can imagine that individuals who are working on that building got an extra few years of work on that site during a really depressed economy. And I can only allude to what I think happened because we were never able to prove anything. Smoking on site is a big issue, and of course we prohibit that. Open flames and embers, we require hot works permit by the building supervisors to make sure that whatever is being done in terms of hot works is monitored. And heating equipment, which is used for the drywall or plasterboard, that needs to be supervised as well. And some of the new ideas that are occurring, and ran across a few years ago in Alberta, which was actually a product of wind-driven fires that occurred in Edmonton, Alberta. And they were concerned about what actually happened was there was a subdivision that was under construction, and there was probably 200 or 300 buildings that were in various different stages of framing, and a fire broke out with a very large prairie wind that was occurring, and it took out probably about 100 or so houses that were under construction. And so there was an entrepreneur, a chemist, who came up with a polymer, which you can see on the right-hand side. In this particular application, they're putting it in apartment buildings to basically reduce the risk associated with costs for supervision and a few other things. And it's a polymer that gets treated on the wood prior to it being constructed. It's a new idea, it's very new, but if we're considering levels of risk or reducing risk, this might be one way to do it. This was an example of burn test. On the left-hand side, you'll see two identical little buildings that were constructed. They put some pallets against the raw wood. And on the right-hand side, you'll note that the one in the foreground is burning itself out, and whereas the one in the back is just about to collapse. And essentially, that's what the inside of it looked like. It didn't go very far. And this polymer, basically what it does, it swells. It creates an insulated blanket for to absorb the heat, and essentially it works quite well. But really focusing on fire safety plans, in our case, it's administered by the fire services and building officials, and it has to be operated by the owner or the developer. They are responsible for adhering to the fire safety plans. And I'm sure that you have various different renditions, but I can always make samples available if necessary. So the future of this, where this is going, is obviously CLT. I think Australia and Melbourne, the first one I ever saw being constructed, I think was around 10 stories. It was in Melbourne. And of course it's caught on in British Columbia this year. And sorry, in Canada, we'll see the National Building Code adopt up to 12-story mass timber construction. And of course, is it going to be safe? And this particular project was the Brock Commons. It was, I think it still is, maybe one of the tallest hybrid CLT buildings in the world. It's 18 stories. I had the privilege of serving on the fire safety assessment team for the building code process in British Columbia for its approval, and it was a pleasure to see this thing going up. It went up like a Meccano set, very, very quickly. Less than several months for construction. Of course, filling in took much longer, but it went up quite famously. And it was demonstrated by some testing that was done by the National Research Council of Canada and FP Innovations. This test was an elevator shaft and an apartment that was adjacent to it. And basically what they did is they fuel loaded it and they put drywall in it. It was unsprinklered. And here's basically the time duration of on the top left-hand corner of the fire commencing, and on the bottom right-hand corner after 2 hours, the fire essentially burning itself out into coals. So that's really been important for our industry to see how this is going to perform. Because once again, we have a tendency to be very, very conservative, which we should. That's our job. But the industry also needs to know that we have to make it affordable, and some of the systems that we put in place have to make that consideration. So, oh, I'm sorry. So anyways, I just wanted to sort of end with an appreciation for the Canadian Association of Fire Chiefs and the Council of Canadian Fire Marshals and Fire Commissioners of Canada, and the Defence Research and Development Canada and Public Safety Canada for funding and putting this kind of a database together so that we can work through and be evidence-based in our decisions, and we can look at vulnerabilities in buildings and make sure that we're going in the right direction. And also Statistics Canada and the Canadian Centre for Justice Statistics, who actually curated the data and put this together for us. And this size of a database is very important to us so that we can make better decisions, so that they're safe. Public safety and firefighter safety is paramount, but also making sure that it's affordable. So that kind of brings me to the end of my talk, and I could probably, I've shortened this up for 45 minutes, but it probably could have went on for quite a while, and but I really welcome the opportunity for questions.
Len, thanks very much for the presentation. I'm just getting a few questions through now, but I might just sort of ask you a little bit. One of the key things when we did our building code change, and it was raised by the fire services, was about fires during construction. So, I mean, we did a bit of background work in that, and there is a Wood Solutions technical design guide that talks about how to consider large buildings from a construction fire perspective. But I was interested in some of those images that you had were like 5- and 6-story wood frame buildings. Did they have any active fire systems in them during that construction, or are they just built fully and then activate the system?
They built them fully, and we had thought at the time that we could maybe convince the sprinkler contractors to follow it up and then charge some of that. And for some reason in Canada, I don't know why, the sprinkler fitters like to start from the top and go to the bottom. And so that was a bit of a conflict. There is, in some cases, we make sure that there's a fire hydrant on the site and that it's charged. We also, where possible, standpipe systems, if they can energize them, depending on the time of year. They need to be freeze protected because we get very cold. So there's some that are becoming very creative, and but for the most part, I think, knock on wood, that we've eliminated the major issues associated with construction fires, and more are reaching out and accessing some of the best practices. And we need to pay attention to what's going on. We need to guard against that. And once they're built, I guess what we're saying, once they're built, we're pretty certain that they're going to perform as well, if not better, than most buildings that have been constructed as their predecessors.
Yeah, I mean, in Australia, our building code does ask that these sort of fire safety measures are introduced when you get to a certain height. I think it's about what we call 12-metre effective height, so 12-metre to your floor. So at that point, we start to introduce our system. So I suppose from an Australian perspective, we wouldn't be building our buildings fully unprotected. All right, just see. There was another question about, has there been any work done on the effect of wetting on the structure itself? So using sprinkler systems. Has FP Innovations done any work on that?
Are you talking under what stage of the building under construction? Are you?
No. If once they're completed.
So once they're completed, we're pretty. The retrospective data that we've seen here basically says that that fire is probably going to rarely leave the room of origin, except under some, extreme circumstances. So that lines up with probably most research that we've seen in terms of how sprinklers are going to perform in the built environment. And so, we're pretty happy, and we're seeing those results in the existing building environment. So you'll notice that the database ended in 2015, and that's when the national building code changed to allow for them in the rest of Canada. So our history right now, up until 2009, is in British Columbia with 10 years of experience in these types of buildings. And unfortunately, as I said, or fortunately, whatever which way you want to look at it, very few fires to get those statistical strength that we're looking for in terms of how those things are performing. But so far, from a descriptive perspective, these fires, these mid-rise buildings that have been built under the additional rigor of NFPA 13 are performing better than the ones previous to that, up to 4 stories. We're performing way better than those.
Yeah. There's a question about just houses. So the typical detached or single family dwelling homes, are there any mandatory requirements for sprinkler protection? I think you mentioned that there were.
The only regulations that we have that are mandating that is done by local bylaws, city bylaws. And so, as I mentioned, there's probably 40 municipalities in British Columbia that have adopted mandatory sprinkler regulations, the largest being the city of Vancouver. And they adopted mandatory sprinklers probably 15 years ago.
Oh,
and
wow.
There's quite a number of other smaller municipalities that followed along, and they've had good results. And we can, this talk did not extract residential fires out of it, although it's in the database because they were sprinklered.
Yeah.
But that work could be done. But you'll see that the results are really promising in terms of reducing risk. If you want to reduce risk to life, the 2 most important things that you can have is first and foremost is a working smoke alarm, and the second is a sprinkler system. And those things combined will give you the best chance of survival.
Mm. Yeah, look, I suppose my comment on that too would be that, in Australia, we do sprinkler all our sort of more commercial buildings, but we don't pay any attention to our sort of single dwelling homes in terms of sprinkler systems.
Exactly.
Yeah. One question was raised about what types of pipework is used typically with the sprinkler systems in North America. Are they plastic or steel, or are they both?
Well, they're both. If they're in a residence, we'll find plastic piping. And if it's in a dry system or exposed, if the pipe is going to be exposed outside the drywall, then it's going to be metal. And so, your parking garages, utility areas, you'll see the steel piping. And then for the most part, embedded in the building will be a plastic piping.
Okay, yeah. Question has been asked about inert gas sprinkler systems. Have they been considered in Canada?
No, there's lots of talk about it, including misting systems, right? And I think that's the next generation to come. And I've always been an advocate of, it could be heresy for a lot of people, but I start focusing on where fires occur, what rooms, and kind of saying, well, if we had a chance to retrofit, I wonder if we could just sprinkler a few rooms, and what would that look like in terms of the casualty rates?
One question, there was a slide, I'll just read the question. It says, in the slide where you showed the red coating, I noticed green studs in the framework. Do you treat the stud framing as well? That's a presumed treatment.
Yeah, in that particular case, what they did is all of that wood is pre-treated with a polymer. They spray it on, and they dry it, and then it's taken to the site and it's constructed. And in those circumstances, it's starting to catch on where there's, as I said, where there's a fear of risk in terms of fire. And this company has been fairly successful in, as I said, in developing its products for these types of vulnerabilities. And it to some degree, it's catching on where communities are concerned about the pre-construction fire risk. And if they want to reduce that, I won't say eliminate it, but if they want to reduce that, then what we're seeing then is they're going to these coatings, and they're making a business out of it. So I guess it's fairly popular. But I'm always interested in something new. One of the things that I saw, one application I saw, which was really interesting, is they're putting this on quarter-inch mesh, and they're wrapping them around telephone poles during the grass fire seasons, because as the fire approaches, the polymer swells up, protects the telephone pole from burning down, and the fire just carries on. So it swells up and protects it like a coating of insulation. So there's all sorts of interesting applications that are happening in order to protect some of our infrastructure. So and they're trying it out on buildings, so we'll see where it goes.
A question about, I suppose, with the code requirements, is all timber lined with plasterboard on the inside, or is there any exposed mass timber surfaces allowed?
Well, that's a good question. Actually, right now, it's completely encapsulated, and there's very little tolerance for open exposed wood faces, and that's where I was so intrigued by what I saw in Melbourne, that one that went up, as opposed to what occurred in British Columbia, where we put 3 layers of drywall on it, and I thought it was a waste, and it was way too conservative. And from what I'm seeing in terms of the fire performance tests, I just don't see the need for it, because it's so, the surfaces and the CLT is so dense. I just don't see a need for it. One of the studies that we're conducting right now is we think we have acquired enough data, and we have a team. Actually, I'm using a biostatistician, because we need confidence intervals at a high level, and we're comparing the combustible and non-combustible environment with safety systems in place, because we just don't believe that they should be, a combustible building can go as tall as it wants to, whereas a non-combustible building can go as tall as it wants to, as opposed to a combustible building is limited to 12 stories. And we don't think that that's, from a risk perspective, that's necessary. So we're trying to prove the combustible versus non-combustible environment with the safety systems in place, saying we think they're equal. And so we want to start those conversations in the building code committees.
Yeah, look, and I think, as you're pointing out during your presentation, that you need to also engage with the various stakeholders to ensure that they're familiar with what's happening and how the systems perform. So, yeah.
Well, we need to have those conversations, in the, and a lot of the conversations that took place before were in the absence of retrospective data. And this is helpful to help, sort of true up those conversations on how we might be able to simulate those from a data perspective, but also doing some testing as well.
Yeah, yeah. All right, Len, I'll have to wind it up there. We're almost up to time. So I just need to conclude today's webinar. So just for attendees, to let you know that there is also another webinar next week, which is titled Pathway to Net Zero Carbon, the Role of Timber and the Passive House Standard. So again, I'd like to thank you all for attending today's webinar, and hope you can join us next week. So once again, Len, on behalf of all attendees, thanks for your presentation.